Good morning, everyone, and welcome. My name is Billy Patel, and I look after Esri's business development and client relationships for natural resources in Europe. I'm facilitating today's webinar along with my colleague, Jeff Allen. Jeff is Esri's global pipeline practice lead and based in Texas, so a little of an early start for him today. In addition to us, I'd also like to mention my colleague, Sarah Powell. Sarah has helped with all the technical setup, and we'd be lost without her today. It's also about 2 a.m. for where she is in the world, so I'd like to give her a special welcome as her efforts often go unnoticed. On behalf of all of us, welcome to our focus webinar on A New Era Begins in Pipeline Network Data Management. Ideally, we'd be sitting face to face, but obviously with everything that's going on in the world, we have to be virtual. Despite that, I think you'll find our time together today to be very interesting, informative, and helpful. Now, please welcome my colleague, Jeff Allen.
Excellent. Thank you, Billy. And thanks everybody for joining us this morning. Wish I could be there in person, but as Billy mentioned, obviously with travel restrictions and such, we're hopefully bringing you this webinar in a time frame that's a little more convenient to you. This is going to be probably a regular practice of us from the pipeline space as we go forward. To kind of continue this cadence of having these sort of quarterly webinars, bringing to you some interesting topics in the pipeline industry. But today, really what I wanted to focus on is some of the new data management, pipeline data management technology from Esri. And one of the real reasons that this is becoming more and more important for us in the industry is this real need to increase the fidelity of the data that we have inside of that system of record, of that single system of truth about these pipeline assets, really building out more details around that digital twin and making that digital twin more intelligent. And so Esri has been working a lot of interesting technologies around this, and that's what I'm going to be presenting to you today. The other real focus that we've had at Esri is trying to unlock this total supply chain data management problem. In the pipeline industry, we've got multiple areas of the industry that we pass through. We could be trying to manage onshore and offshore gathering assets. We have the traditional sort of midstream pipeline operators that typically deal with linear reference systems, and then all the downstream terminals and ports that we have along the way and all the facilities that run inside of those, as well as all the stations and pump stations and compressor stations along these routes. In sum total, what we're managing here is pipe data, right? From that wellhead to the burner tip and everything in between. But how we actually manage and model this data in the GIS, for those of you who've been doing it within the GIS tool set, you know is very difficult. We often have different modeling techniques. We have different data types that we need to manage along this supply chain. So Esri has really been focused on coming up with a combined solution that allows us to manage all this pipe in a single enterprise geodatabase, all connected and all interworking together. And so to that end, we really have two pieces of technology that I'm going to be focusing on here today. Again, the real driver here is to be able to model that pipeline system continuously. And that's going to bring into play two tool sets. One is ArcGIS pipeline referencing. ArcGIS pipeline referencing is going to take care of the linear referencing needs of that supply chain. And then the utility network underpinning that is going to be that more connected pipes. And this is going to give us a lot of new capabilities around how we can trace and how we can analyze these pipe networks and really look at this as one seamless layer of data from beginning to end with the linear referencing sitting on top in the middle bits. So as we now think about bringing that utility network functionality into the picture, we're going to open up some new capabilities. Obviously, mapping is going to be a huge part of that. It's core to our software, it's core to our system. But beyond that, we're also going to now start layering in some functionality around schematics, or what I like to call alternative views. How can I take that mapping data and then turn it into a view that somebody in operations can easily understand, see how flow diagrams are put together. We also are going to introduce the concept of what we call component views, where we can actually have a GIS within a GIS. So now I can have an object in my GIS, and I can actually give it details inside of that object, right? I can really build out what's going on inside these facilities, and yet keep that information clear and understandable from the geographic point of view. Once I've layered in the utility network, I'm going to turn on some advanced analytics. We'll look at some tracing routines and some intelligence built into the actual objects themselves. We'll be able to support historical and plan views. So as we start building out and designing pipe within this network that's to be installed, we can actually add that pipe to the system, have that part of the utility network and part of the linear referencing system, and then sort of turn that on as it becomes energized. And then finally, we'll be able to look at all this data not only in just 2 dimensions, but now we bring in a 3-dimensional component itself. So both of these tools and the entire stack supports both 2D and 3D pipes as well, and the visualization of those assets in 3 dimensions. Now, one of the things as you move into this new technology, you're going to see is different from Esri. Is traditionally you've probably been used to using a desktop tool like ArcGIS Desktop connected directly to the underlying database. With these new technologies, both ArcGIS pipeline referencing and the utility network now use web-based services. So that becomes the server itself takes a much larger role in the picture and offloads a lot of the work from the desktops onto the server itself. And why this is important, because 2 reasons. One, we can now introduce, from the utility network side, we can introduce a rule base. We can have business rules that sit on that server and sort of protect that data. And so only data that passes our rules can make its way into the enterprise geodatabase, as well as to be able to open up access to that data through editing through multiple platforms. So not only can I do editing from my desktop, but I can do editing now from a web application or from a mobile device as well, all hitting that same web services. So we open up the data editing workflows to a lot more people in the organization. We can offload a lot of that work that the GIS professionals had to do before onto the line of business, who can now edit and maintain some of their own data sets. Now, underlying this, if we were to kind of pull the covers off a little bit, there's 2 pieces of data modeling that we need to discuss this morning. First is how we maintain the connected assets, right? So these are going to be the assets that are under pressure, I like to say. These are the assets that are going to be part of the utility network. And the way that we've organized these are in a couple of high-level feature classes inside the enterprise geodatabase, right? It's not as important as what's inside these buckets, is that these buckets exist. So from the utility network perspective, we're going to have devices. Devices are objects that control the flow. This could be like a meter or a valve or a pump or a compressor. We obviously have the lines themselves. So the pipelines are actually going to be here in the utility network layer. We have junctions. Junctions are like fittings, like T's and taps. And then we have assemblies, and these are those larger objects, like a launch receiver assembly or a well set assembly, or a collection of objects kind of glued together. And then we introduce a concept that we call the subnetworks, which are sort of logical groupings of lines in the system that are really based off of where devices, where those things that control flow belong along the system. So these are some key feature classes that we need to add to the enterprise geodatabase to turn on this utility network functionality. Now, included with that, we're also going to add some key fields for the linear referencing capability. So here we have a centerline object that dictates where the geometry of that pipeline is going to go. We create on top of that center line a set of routes. Routes are the sort of logical chunks of the pipeline that we define between 2 points that have continuous set of stationing. And then finally, a set of calibration points that allow us to control the measures along those pipelines, right? So for modeling and managing this pipeline data, that the true length of the line, the true steel in the ground is very important to us. And we use calibration points to represent that inside the GIS. So you've probably seen these two data models independently of each other. What I'm going to show you today is that combined model. And in the combined model, what happens is we actually lose the centerline layer from the ArcGIS pipeline referencing model, and it get replaced by the pipe feature from the utility network. Right? This is the key that glues these two pieces of technology together. The center line for my linear referencing is my pipe in my utility network. If you can remember that key fact, it'll unlock the whole stack for you. Now, though we can consider those information models, they're really not a true pipeline model, right? They're just the key bits that we need from Esri and the enterprise geodatabase to make these editing tools work. So if you were to open up a full pipeline data model like pods or like UPDM in this example on the screen, you'll find those pieces of the puzzle inside of here. So inside of the UPDM 2018 edition, you'll find the oil and gas network. This is where we first introduced the utility network asset package into UPDM. And you'll also find the pipeline referencing tools or tables inside the integrity data set. So this is the UPDM 2019. We continued this pattern in the 2019 version of UPDM. You'll find that same thing. It was basically with some minor tweaks to the model. And we'll be delivering UPDM 2020 here right around the user timeframe in July. Again, I'll have some more functionalities, some more objects that we've modeled with inside a pipeline database, but just know that UPDM contains the two smaller bits, which is the utility network core and the linear referencing core within it. Now we also support other industry data models, right? So we, Esri and Pods has also worked very closely to integrate the ArcGIS pipeline referencing tables into the current version of Pods, Pod 7 that's available today. And currently Esri is working very close with Pods on a technical committee to integrate the utility network functionality into the Pods model as well. So right now, the only data model that has both utility network and APR is the UPDM model, but hopefully here in the next couple months, Pods will also support both UPDM and Pods in the same data model. But they're not limited to just those two pipeline industry standards. We can also implement this technology in any schema that's an enterprise geodatabase. So as long as we implement those core data feature classes and the configuration of those feature classes appropriately, we can actually turn this technology on in any pipeline data model that you might have. So I'll take you through a couple of slides here and then we'll really get into the demos. I'll start with these network rules. It's really the foundation of what we're doing now in the combined system. The network rules are beyond just the geometry rules and beyond just the topology rules that we would build typically into an enterprise geodatabase. This really brings in the concept of business rules into the system. So here I can define how pipes can connect with junctions, how pipes can interact with devices, how junctions can interact, how devices can interact together. I can basically build up a set of business rules that my data has to pass before it makes it into the enterprise geodatabase. And this comes, the UPDM model comes with a configuration of about 3,000 business rules already built into it. There are tools within the system now that you can modify, maintain, add, delete, modify any rules that you'd like. But just know that this functionality exists and it's part of the core information model as we build up the tools. I talked a little about containment, right? This is the idea of having a GIS object within a GIS object. So here I have an object that represents this pump station. And inside of that now I can open that up and fully describe all the objects that contain within it. The pumps, the bypass piping, the valves, all that information that I would have about that facility stored within inside that single point or that single polygon on the map. Now, terminals are very important to the utility network as well and to the combined system. What terminals do, it allows us to add intelligence to devices along the system. So for example, I have maybe a valve, and in this example, maybe it's a check valve. Normally I would place valves as just simple point events in the GIS, but here I now defined both ends of that valve. And in the case of a check valve, it's very important because the product can only flow one direction. So as I place this valve into the system, I basically wire it to the pipes on both sides, and I tell it how that device now interacts with the pipes that connect into it. This is the same for, say, a compressor or a pump station. I might have a low side and a high side of the pressure that comes in and out of these devices. This is what controls the flow through the utility network and controls the flow through our model now, not based on the digitizing direction, but how these terminals and how these devices are actually connected to the pipes. So here's a couple of different examples of those terminals. I can have high to low pressure. I can have generic inflow and outflow. I can have bi-directional flow. So some of our systems flow unidirectionally. So I can define my terminals to handle that. I also have the ability to model other things besides pressure. And what we've done here is we've actually added a cathodic protection module as well. So we can now model current inflow and current outflow, and not only model things like pressure systems, but also CP systems. So tell me not only what's connected together under pressure, but what sees the same electrical connection, and how can I manage that and model that within the system. So these are very important, these pressure systems and these pressure devices, because as I start looking at entire systems of objects, in this case, maybe this is a pressure system, I can now accurately model that within my system and have these devices have intelligence now. And as I see all the fittings and all the devices and all the pipe that are connected together under the same pressure, I can do some interesting analysis. Like here, I can look at this pressure system and report back what's the lowest MAOP of any component within an entire pressure system and get that result back to me. So very, very important from an engineering standpoint to be able to understand how these objects are interconnected together and do some interesting analysis on these, like an MAOP calculation. Now, these are all dynamic, so as I add new fittings to the system, they're all seeing the same pressure. I can rerun this calculation and dynamically update this value on the fly as I add components to my system. And then finally, some new functionality we bring to the table is trace. Right now that I have these pipes in the GIS and they are truly connected together, what can I do to look at that? I can look at isolation zones. What's the nearest upstream valve that would shut off this part of the system? Pressure zones. What are all the fittings and devices that see the same pressure? I mentioned the cathodic protection zones, looking at CP test and which part of an object is in or out of a CP zone. So a lot of just interesting things that we can enable and turn on with this functionality. And remember, these are not just limited to the desktop tools, right? The real power of this is that these tracing routines are available through the web and very soon available on the mobile devices as well. Right now, these operations are supported in the mobile runtime. So I can build these tools today from the runtime, and very shortly they'll be enabled in the off-the-shelf tools like Collector as we move forward in the journey. And then finally, network diagrams. These are this, or what I call this alternative view of what we have in the GIS. So not just the geographical view, not the geographical maps, but things like smart tree layouts and junction reduction layouts. So I can now give alternative views to the operations of how these fittings and how these devices are connected together, and then publish those out as maps that people can easily digest and utilize with the rest of the platform. So these network diagrams have been around. We've had ArcGIS schematics for years, but these network diagrams are now core and part of the utility network functionality and experience. So with that, let's drop away from the slides, and I'll switch over and I'll show you some of this in a live demonstration. So for this particular demonstration, I'm going to be using some of the European data set that we've built here at Esri. So we have a US-based operations, and this sample pipeline, this is nobody's particular data. This is data just we created in-house for our own use. But it shows some interesting example. Here I've got what I've meant to model is some offshore assets, and then some long undersea transmission pipeline finally making its way onshore, into some onshore transmission and into some onshore facilities. So I'll take you through the bit of a components here, but we'll start really with that sort of offshore look. So here I'm just going to zoom into our offshore assets. I've obviously got some land-based features bringing up behind it, some boundaries and tracks and offshore lines. And in here, what I want to show you really quickly is that, as I start building out these connected pipes, I've actually defined these wellheads as the beginning of my systems. So I've sort of built into the model here a bit of a hierarchy. And if I just give you a quick preview of that, I can see where the pipes are themselves. But if I turn on the system layer inside the utility network, I can actually see all the pipes that are connected together in the same system. So because these wellheads control the beginning of my systems, I see all these pipes sort of gathered together here and then running into this collection point here. And as I zoom in and take a closer look at what's going on here, I can start to reveal some of these components that I mentioned in the overview. So here we have some platform or underwater collection assembly where I've got these pipes flowing into them. And you can see here I really don't know exactly where everything is located geographically, but I have sort of a layout, a schematic layout of what's going on here. And so I have a container, and if I just quickly go onto the utility network and show the connection objects, I can actually show that I have the sort of virtual connection of these objects together. So I have these lines flowing into to a mainline valve, shutoff valve. I have two metering devices here showing the flow coming in for these valves through a T here, and then into my my delivery valve, my delivery pump, and then I've got an isolation valve here. And if I was to actually look at one of these devices, let's look at this pump here. You can see I've got this defined as a controller object. I've given a name, offshore terminal pump, and I've given a subnetwork name. So this is really defining how the pressure of the outside outflow of that pump is connected into the system. And if I want to look at the connectivity of that object, I can just quickly click on the pump itself, and I can see I've got the low pressure in connected to that meter. I'll just highlight it, and the high pressure out connected to that valve. So now I've defined the flow of that valve, of that pump. I've defined how it's connected to the devices on either side, and now I have a fully connected model at this point. And if I wanted to show that, I could do a quick connected trace. So let's just add a trace location to start at one of these wellheads. And I'll just run a connected trace on the system. And you can see it's automatically discovered everything on those offshore lines, everything on that platform. And you can see it's actually traced its way down. And if we zoom out a little further here, it's actually found all the facilities all the way down onto the onshore system. So the quick trace, I can now discover all those fittings and all those assemblies all the way down through my onshore, all the way ultimately to the terminal on the other end. You can see quite performant from a tracing capability perspective. Now, if I switch modes onto sort of my more onshore-based network, I'll show you a little more connectivity here. So again, I've got some offshore assets as I come in from the offshore line into my facility here. I've got some onshore devices. I've got another meter point, some more mainline valves, another pump assembly. Again, all connected in the network. And if I just turn that connected view back on, I can now see how those are all traced and connected together. But now here is where I actually jump off of the utility network and start onto my linear referencing system. So here I've actually started to define my linear referencing system. And if I go ahead and turn that on, you can see this is where my linear referencing system begins. I start having my measured pipeline and my calibration points and my measures along my transmission line. So again, seamless transition, the linear referencing network is sitting just on top of the pipes. So these are the pipes in my utility network. And you can see I've got my pipes sort of organized by their type. So I can see my gathering lines transitioning into this facility and then onto my transmission pipe, which then has that linear referencing turned on in it. And then as I move myself further down the system, I'll go to the next terminal point. So you can see the transmission line here again coming into this terminal. And I've got a number of terminal pipes here defined. So here I've got some more pipes coming in with linear referencing. Just turn those linear referencing lines off. You can see I've got the T, and here as I jump onto my station pipe, I come through this meter assembly into the pipe on the valve on the other side, and then connect on through into these fittings over here and eventually into my offshore or offloading platform onto my shipping containers. So again, these pipes are transitioning between linear referencing and non-linear referencing pipe. So if I turn the linear referencing network on here, you can see I have all these pipes along my main line measured through this mainline valve and then down the other side and continue on downstream. This pipe inside the station is just station piping. I don't necessarily need linear referencing, but again, it is all connected. It is all discoverable in the model, and these devices now control the flow of those through the system. And then eventually, if I go all the way down to the other end of the system, to that port I have, I can jump off the end of the transmission system into this container here that has all my pressure systems, all my pumps. I transition from my pumps into my storage facility and all the pipes within inside of here. And you can see as I come down a little closer here, I have this valve box. This valve box is going to be a container. And if I was to just enter that container, I can expose the container edge here. I can enter that container and now expose more details about what we have inside of this object. And here, when this finishes and opening up, I'll show you all the different fittings and facilities within inside of here. So I can see all the pipes, all the details. So these pipes are fully connected, but they're contained within this boundary object here, this polygon. And this can be represented as a point or a single polygon, with all the devices inside of it. And if I modify that container, you can see all the different devices inside of here. So here are all the devices. Now, if I wanted to make some of those devices visible outside of the container, I could just turn this visibility on here, apply that. And as I close that container and exit it, that valve is still going to be contained, but now it's going to be visible outside of the container. So it's still part of that containment, still holds those attributes that say it's contained, but now I can see it at the mapping level. So let me show you how we build one of these lines. So I'm going to zoom over here back to that terminal. And let's take an example of, we have our linear referencing layer. And what I want to do is I want to actually add to my network. So I'm going to add to my pipes a new delivery. So we have a file that came in from an as-built drawing or a survey of this new route that I want to add to the network. And I also want to define a linear referencing system on that pipe as well. So remember what I said, the first thing we need to do is we need to add this pipe to the utility network pipe layer. And to do that, I'm going to do a simple selection. This pipe is just sitting in a file geodatabase as a simple shapefile. And what I'm doing is I'm going to copy. I'm going to just paste that into my transmission layer. This is my transmission pipe layer inside the utility network. I'm going to go ahead and paste that line into there. And if I shut off my supporting layers and clear the selection, you'll see I have that new pipe in the utility network. Now, obviously, I'll need to give that pipe some attributes. So I'll select it again. And for time's sake, I'm just going to give it a couple of key attributes. One, I'm going to define its asset type. So this is going to be a coated steel pipe. And the other important bit from the utility network standpoint, or the linear referencing standpoint, is I need to define the begin and measure of my pipe. This is what's going to give that the start of the measures to my linear referencing system. So for this example, I'm going to give a from measure. I'm going to start this at 0, and a to measure, and I happen to know that this line is 1,250 meters long. This would be the pipe length of that line. I'm going to apply that. Now, because I've added this to the utility network, I'm going to go ahead and want to validate that, make sure it passes all my rules, which it does. And now, before I add it to the linear referencing system, I can go ahead, any devices or junctions I want to the network at this point. And these are all using standard editing tools. So for this example, if I wanted to add that T at that connection point there, I can just add this. Let's add a metal 3-way T. And I'll add that right to the endpoint of the line. Whoops. Sorry about that. Good thing about this is we're using services, so I know it's going to be able to pick up right where I left off. So I've got that T and that new pipe. Now I want to add that to my linear referencing system. So here what I'm going to do is use my location referencing tools. I'm going to hit create because I want to create a new linear referencing network. I'm going to select the center line. So remember, the center line is the pipe from my utility network. So I've selected that center line, which is my pipe. And now I'm going to create a linear referencing network on top of that. I'll use today as my start date. I'll give it a line name and a route name. And you can see it's automatically picked up my begin and end measures from my begin and end station that I had placed on that pipe record. Now if I run that, and turn on my linear referencing system, now you can see that linear referencing has been added to that utility network pipe. So now I have measures along the route. I can go back in, I can switch over to the event editor, and I can start adding any linear events that I would have along this route. So I've got my fittings in the utility network. I've got my pipe as my underpinnings of my center line. And now I've got a completely measured center line that I can start using and adding linear referenced objects to. So both working together. If I'm to modify the center line of the pipe, I'll automatically modify the underlying pipeline, which will automatically modify the route for me as well. So both working together. And again, the key here is that these are all connected. I didn't have to do anything to the model. If I go back to that example of my connected trace, let's just go ahead and validate that, make sure it's all validated. This time I'll just set a trace location. Oh, I don't know, let's set it back here on the existing line and then just run a simple connected trace to show that that new line is automatically now part of the system. And you can see all those pipes are connected together now. So because that line was topologically correct at the outset, I didn't really even need that point for my connectivity, but it helped define all the pipes in between. And now that piece of new pipe is now discoverable through the trace algorithm. It's also discoverable through the linear referencing system. So let's look at some other interesting use cases for trace. I was just been doing a very simple connected trace, but let's utilize something that has a little more use in the real world. In this case, what I'm going to do, I'm going to go back to the utility network, and let me just remove that trace location. I'm going to trace on what we call a subnetwork. So remember, these devices have intelligence. And in this particular model, what I've created is a number of subnetworks that define a couple different pieces of the system. So I have my system subnetwork that shows me the connectivity between all those meters. So this is where my system breaks. I have my pressure systems, and the pressure system is going to dictate where pressure in the line changes, and that is dictated by where I have pumps along the line. So if we zoom in on this particular pump station here, you can see on my pump definition here, and I have two pressure systems on either side. And then lastly, I had defined an isolation system that shows where pieces of the line are isolated between valves. So this blue piece of the line is isolated, can be isolated either by this mainline valve here or this mainline valve just inside the station. So again, these systems or these subnetworks are being defined by the connectivity of the objects that defines them. So all if I had to do if I wanted to create a new isolation zone is I would just add a new valve assembly here, and these would be broken into 2 isolation zones. So I'm going to look at that pressure zone again, and I'm going to do a subnetwork trace. And what I'm going to do is I want to look at all the devices that are found within a particular pressure system. So I'm going to do a subnetwork trace on my pipelines. And I'm going to look within that pressure tier. And I'm going to pick a particular subnetwork. I have one in mind. I won't even try to pronounce it. And you can see what it's going to do is it's going to find all those fittings and all those devices that are part of that pressure network. You see it's automatically found my new pipe because obviously it's connected with a T from that upstream pump all the way down through. So it's found that new little lateral, and it's now discovered all the devices all the way down until I hit the next pump, which happens to be all the way down at the end terminal. Now you can see that this is just a simple selection set, right? So you can think of all the different things I could do with this now. I could then send this into another process. I could use that selection set in a modeling. I could discover and iterate through all the components along that line to do min-max MAOP calculations. But in this particular case, what I did is I used those selection and I used the diagram tools to actually create a new diagram, a new conceptual layout for that pressure system. So when I did that, I just happened to select and symbolize just the main components of the run. But I have, the new lateral now. I have this high pressure offtake to the delivery of that shipping terminal, and I can see my inlet pump or my outlet pump and all the controllers and all the meters along the way. So again, this is just a diagram layout that I applied to that selection set. In this case, I just happen to use a mainline tree diagram. But you can see we have all kinds of different diagram layouts that can be applied to this and view these in different ways. So again, these are all tied real time to the map. So if I was to select, say, this mainline valve here, I can apply that selection set back to the map. And if I select back to the mapping view, it's automatically highlight that valve for me. And I can just zoom in and see exactly where that valve is in the mapping system. So I can move back and forth between these 2 views. I can publish these views out to my portal. I could connect these views, since these are simple objects, I could connect them to other systems. So if I wanted to maybe display real-time SCADA information at, say, this meter, I could tie those systems together and have a real functional view of what's going on inside this, this overall network. And so the last piece of the journey today I want to talk about is we've been looking at all this in 2 dimensions, connectivity, associations, containers, and I did mention the 2D and 3D view as well. And so here what we've done is we've taken a bit of utility network and linear referencing network, and we've added it to the map. But in this case, these pipes actually all have 3D or Z information associated with them. So if I was just to select one of these pipe objects here and just simply look at their attributes, and then just flip over to their geometry, you can see I have elevations at each of the tangents along each of these pipes. When I do that now in ArcGIS Pro, I can simply take these pipes and add them directly to a 3D scene. So these are the same feature services coming from the utility network and APR, viewed in a 3D scene. And now you can see I can show above ground And if we turn off the elevation surface, all the below ground piping. Now, if we want to get really detailed and go inside of say, one of these containers, in this particular case, I've got a 3D model coming from a CAD drawing, an as-built of this particular pump station. And I can peel away the surface of this building and go inside and look at more details. And you can see exactly where we've built the utility network from, looking at these 3D objects. So you can see now the pump, the valves, the T's, the reducers, the meters, all in 3 dimensions, all overlaid with their utility network components and all connected together. So there is the utility network objects and their devices overlaid on their 3-dimensional objects that came from either a 3D laser scan or an as-built drawing of this particular station. So a lot of people have this data locked away in CAD drawings or other 3D drawing systems. Now we can bring it all together. We can have the full story of the transmission pipeline, above and below ground piping into the facilities, one model, utility network, and linear referencing all living together inside the same geodatabase. And with that, we will open it up to some questions. Billy, how did we do?
Thank you, Jeff. There's a number of questions that have come through along a similar theme, so I'll kind of combine those together. If somebody was interested in how they can get started with APR and the utility network, how would they go about that?
Absolutely, great question. So we've been doing a lot of enablement programs, both through Esri Inc. and in support of our Esri distributors throughout the European region. So we have both distributors and business partners that are up to speed on both ArcGIS pipeline referencing and the utility network. Most of our customers are starting out small with a pilot project with some evaluation licenses, take some of your existing data, load it in, sort of kick the tires, see how it works, and then moving on in their journey to larger pilot implementations of actually converting their data sets, and then eventually going into full production. So if you have any questions about who in your region of the world might have utility network and APR capabilities, simply reach out to your Esri rep first, your Esri distributor, and if not, reach out to either Billy or myself, and we can get you connected with the people who have the skill sets to help enable this inside your Esri environment.
Great. Another theme was around international units of measure, Jeff. Does the APR and utility network fully support different international units?
It does, actually, and we've done a lot of work inside the UPDM model to make sure it's not North America centric, right? We have, and actually some of the earliest and largest adoption patterns of the UPDM data model were our international customers. So the data model today I showed you was fully in the metric units. And you can see that I've modified the display of my stationing to use the kilometer post measurement system, but I can easily switch back to the US or imperial units as well, and I can have a mixture of both. I might have my measurement system in meters, but my pipe diameters in imperial units. So lots of different ways that I can mix and match inside the data model. We do handle that all within the system.
Great. There were a couple that may have come in before you showed this in the presentation, but just for absolute clarity, are both onshore and offshore equipment types supported in the industry, in the two industry models?
Correct. So yeah, we've done a lot of work both on the pod side and on the utility network side to support that gathering cadence, both onshore and offshore. The other important part to understand on both of these models as well is that they're quite expandable. So if you have other equipment types, other connection, other business rules for your particular operations, we can easily accommodate those in the model. That's not a customization, but simply a configuration of the tools. to understand those new devices and those new junctions and those new assemblies, and then be able to work with the tools just as I showed you with some of the out-of-the-box objects.
Great, thank you, Jeff. And a couple that are a bit more technical and specific, more operational. What would happen if all rule requirements were not made or were not met while inputting an object, and what kind of user experience can one expect?
Yep, so I didn't go into that level of detail, but basically what happens is when I run that rule validation against the data, it creates any errors that it finds in the rule base. It creates an error log for you, and it actually creates points and lines on the screen to show you where those errors are. So those objects can exist in the geodatabase, and they'll have those rules associated with them. And you can save the data, you can continue on, you can fix those errors over time. But obviously things like the connected trace and some of the other analytics will be prevented on those objects until they pass that rule base. So they can be stored in the geodatabase. You will see where those errors lie. You can fix those errors, and then once all the rules are passed, then that data is available for all the analytical tools.
Thank you, Jeff. A question related to 3D. From the presentation that you provided, does that mean that linear referencing, the APR model, does now support calibration on vertical pipes, for example, a riser?
Yes, that's a great question. That's actually one of the last pieces of the puzzle that we've been adding. And now at the 10.8.1 release, we should be able to support that full vertical 3 dimensions of the vertical piping as well in the utility network. I mean, in the linear referencing network.
Great. And if we've got time for one more, Jeff?
Absolutely.
How does inline inspection, or how can inline inspection data be integrated into this model?
Yeah. Yep. Great question. So as you saw when I added that lateral and I added the measurement system to it, I happen to be adding the engineering measures to that line. We can also have multiple measurement systems sitting on top of that single pipeline. So in that example, I had one measurement system, my engineering stationing, but I could have added to that another alternative measurement system, say for my odometer readings. And then to those odometer calibration points, I can then apply all my ILI data. So there's a couple schools of thinking here. One is to store the ILI data in its initial calibration, or flip it to its engineering equivalent and store it in the engineering network. You can actually do both directions. We've seen some interesting patterns, most notably from Rosen, who has now built tools on top of APR and utility network to do auto alignment of objects like welds and valves and T's in the engineering network to the ILI data and help automate the process of bringing that ILI data into the tool. And the last point there is that the measurement systems or the calibration systems along those lines don't have to be limited to just measurement systems. We've done some interesting work where we've calibrated the pipeline to time. And then we've taken a data set, in this case it was a cleaning pig, which didn't have any odometer readings to it. It just had time associated with it. And what we did is we used time 0 at the launcher and then the end time at the receiver, and was able to calibrate that ILI data to that line, not using geometry as much as length, but time, which then correlated to distance, which then showed me those objects on the screen. So it was an interesting experiment to try to use some of this additional data that doesn't have a geospatial context, yet to bring that into the system and make it usable in sort of the overall information system. Well, excellent. Well, thank you everybody for joining us, and we will, as Billy mentioned, we'll make this recording available to everybody that joined us today. We'll also have a finished version probably available in a week. And then we'll also collect up any of the other more technical questions, and we'll publish those to everybody that attended as part of an FAQ. And of course, as always, if you have any additional questions you'd like to ask one-on-one, Billy or myself are available anytime via email. You can reach out to us and we'll be happy to engage with you. Thanks, everybody. Have a great rest of your afternoon, and thanks for joining.